This experiment shows how we find Young's modulus for a material. The problem with the stiffness constant, which we measured in the Hooke's law experiment, is that its value will depend on the dimensions of the material used. If you want to be able to compare materials, we need a measure that is independent of the material's dimensions. This requires us to use tensile stress and tensile strain rather than just simply force and extension. Young's modulus is defined as the tensile stress divided by the tensile strain. Tensile stress is defined as the force applied divided by the cross-sectional area. In the experiment, the force applied is due to the weight of the cradle, and the cross-sectional area is that of the guitar string. We can calculate the cross-sectional area by looking at the sleeve the guitar string came in and seeing that its dimensions are described here. You have the diameter both in inches and in millimeters, and of course you can use that to simply calculate the cross-sectional area using pi r squared. So the experiment proceeds exactly as the one for Hooke's law. The tensile strain is defined as the change in length as a proportion of the original length. In the experiment we measure this from the angle turned by the spindle, which is attached to a pointer here against a protractor that we can measure. So the change in angle of the spindle tells us how much the string has extended. So this is repeated for various weights here. You take a measurement of the extension by looking at the angle that the spindle has turned. Then for all the weights, all the different weights, you can calculate and then plot the tensile stress against the tensile strain, and because Young's modulus is defined as the tensile stress divided by the strain, the gradient gives you Young's modulus. Okay, thank you.